Hi everybody, and thanks for tuning in to our video on scatter plots and best fit lines. I'm pretty sure you've seen this before, so this will serve as a little review from last year. As I like to do, I like to start with what the heck a scatter plot or best fit line is. So we're going to read these 3 bullets together. We're going to draw some best fit lines. We're actually going to skip. We are going to skip, not that it's a bad problem, but I want to skip this one as an example, and we're actually going to do this number 4 later in the packet as our example because I think it's more interesting. So just write a little skip here. You could always do it if you want to on your own, but I've got a better one in store. So let's read through these bullet points. So bullet point number 1 says, a scatter plot is a set of points that represent data. So we're talking real world now, people. We plot these points and try to find equations that best approximate their relationship. Because data is not always perfect, not every point will fit on the line of best fit. Okay, bullet 2. The line of best fit is the line that is closest to all the data points. It can be used to approximate data within the set or beyond the set. Scatter plots almost always represent a real-life situation. And the final bullet, scatter plots can have positive correlation if the x and y values increase together. They can have negative correlation if y decreases as x increases. And if the points have no sort of linear pattern, then the data would have no correlation. Okay, so I've got those 3 examples right here. So you see this positive correlation here. See, as x increases, so does y. See, as x goes up, the y's go up. I like to think of positive correlation as positive slope. That's how I like to think of it. If the line has a positive slope, then it's got a positive correlation. Here's what a negative correlation looks like. You can see that as x increases, the y decreases. I like to think of this as negative slope. And finally, no correlation. The way I like to describe no correlation is a little graphic, but it's the truth. It looks like someone just vomited a bunch of points right onto the plane. Look, it's just like pleh, and there they are. No rhyme or reason, no pattern. That's no correlation. See, these are like, you can see the flow here. I say go with the flow, or these, go with the flow. You could almost envision a line going through there. So that's what we're going to do next. So we're going to grab a ruler, and we're going to draw some best fit lines. So let's take a look at this first set. I have 3 rules. 3 rules when it comes to drawing a best fit line through data. Rule number 1, go with the flow. So like, do not take a set of data with a positive correlation and go drawing a line through like this, like drawing a line this way. Are you kidding me? Go with the flow, okay? Next, try to hit as many points as you can. Try to hit as many points as you can, but for goodness sakes, do not do this. I have had students in the past like half giving me a headache thinking about it. They, honest to goodness, did this. Try to connect the dots like that. Are you kidding me? Heck no. Don't draw zigzags. You try to hit as many points as you can coming through the middle here with a ruler. And rule number 3, try to keep an equal balance of points both above and below your line. Like, don't go making a line here. If you draw a line here, all your points are going to be on one side of the line. You don't want that. Don't draw the line there, or all your points are going to be on this side of the line. Come through the middle. Hit some. Keep an equal balance. It's pretty simple. So, without further ado, let's draw a best fit line through this data. Now, I'm not going to do a perfect job here. I'm just going to guesstimate. Boom. There I go. Looks pretty good. Let's do one through here. Boom. Looks pretty good. Got some under, got some over, got some on the line. Perfect. This guy, I'm not drawing anything. Remember, no correlation. Okay, so we're skipping this one. Now, your mastery. I'm bleeding into the mastery here. So what I want you to do is for numbers 1, 2, and 3, I want you to decide what type of correlation you have, positive, negative, or none, write that here, and then draw lines. If there's a correlation, then draw a best fit line. That's simple. I'm more curious on this video to go to number 4. We're going to actually use some graph paper to draw a scatter plot, draw a best fit line, write the equation of the best fit line, and then make some great predictions from it. So let's take a look at what number 4 says. It says the table below shows data collected on a Chicago Bulls game, basketball fans, from several years ago. The table displays the time elapsed in a game and the points on the scoreboard for the Bulls at those times. And can I just tell you, this is real. This is real data. A former student of mine by the name of Danique, if you're watching, I'm giving you a shout out because I cannot take credit for this data. Danique was a Chicago Bulls fan and we needed some data, and he offered to watch a game one night and bring us back the data. So I said, okay, Danique, let's form a bit of systematicness to this. I said, with the times, I want you to take them at 6-minute intervals. So, you know, like as the bottom of the screen on the TV, as the time would elapse, he would take the scoreboard score off for me. So he did it at 0 minutes, 6 minutes into the game, 12 minutes into the game, et cetera, et cetera, et cetera, up to he stopped at 48 minutes. And I forget why Danique did that. I think he had to go somewhere. Something happened where he wasn't able to like finish out the game, but he got enough for us. Okay, so that is real data. I just want you to know that. Now, what does part A say? It says, draw a scatter plot of this data on graph paper. Be sure to label your axes. Okay, so the time is going to be our X, and the score is going to be our Y. Remember, Y is dependent upon X. The score of the game is going to depend on how much time elapsed, not the reverse. The time does not depend on the score. Can you imagine if time in our universe depended on this or depended on anything? See, time depends on nothing. Time ticks regardless of what's going on. Can you imagine though if like as the Bulls scored more points, time sped up? Imagine if that happened. Like so when they put, oh, look, you're scoring. Let's speed up the time. No. The score depends on how much time has elapsed. So this is our X and Y. Okay, so what we need to do is label that accordingly. So I want you to get some graph paper. And on the X-axis, I want you to call the X-axis the time measured in minutes. And then the Y-axis is the score, and that's measured in points. Pretty simple. One of the hardest parts of this problem is going to be deciding how we should increment. So if you look at X's, well, they're going up by 6's, so why not just go up by 6's on the X-axis? That makes sense to me. So we'll start here on the corner with 0 minutes, 6 minutes, 12 minutes, 18, 24, 30, 36, 42, and 48. And that was the end of the data, 48 minutes. Now going up the Y, boy, oh boy, we have to get from 0 to 118 points. So we most certainly can't go by 1s. We most certainly will not make it by 2s. I've done this problem before on this sheet because I did it as an example in class, and I'm pretty sure if you go by, oh, I may have to redo this. 6's may work, or is it 7s? Let me try 7s. You ready? Don't do this yet. Actually, I'll do it in pencil to start. Okay, so this would be 7, 14, 21. I'm hesitating. I'm doing my mental math with half a headache. 28, 35, 42, 49, 56, 63, 70, 77, 84, 91, 98, 105, 112, and 119. Yes, indeed, I remembered it correctly. It is going by 7. So let's do it permanently. 7, 14, 21. And I mean, you can go by other things too. I was just trying to use up all my space so that our dots might be more accurate. 84, 91, 98, 105, 112, and 119. Perfect. Okay, now we're going to start to plot our data. So we're going to plot these as ordered pairs working down our table. So let's see if I can kind of keep this close by here. Can we see both of those? Okay, so 0, 0, simple right here, 0, 0. Then I've got to plot 6, 22. So here's 21. 22 is going to sit right on top of that. 12, 33. Okay, so that's going to be underneath 35. 18, 40. Maybe about right here. 24, 57. Just above 56. 30, 76. Right below 77. 36, 92, so let's come up, here's 91, so 92, just right above. 42, 109, so here's 105, 105's here, so we'll say 109, maybe like about right there. And then 48, 118, that's going to fall right underneath 119. So there is my scatter plot. Now you can see, I'd have to zigzag to connect all these. So that's what makes it a scatter plot. The data is not perfectly linear. And how could it be? Can you imagine telling the Chicago Bulls, all right guys, here's the deal. Every 6 minutes, you have to score the same amount of points. Can you imagine trying to tell the Chicago Bulls that? It just wouldn't be possible. So real data very rarely lines up perfectly. But what I do see here is a very strong, positive correlation. See how as the time increases, so does the score. As X increases, so does Y. And really, I can envision it. I can envision drawing a best fit line through here. It just kind of looks like a line. So that's what I'm going to do next. B says draw a best fit line through the data. So I'm going to line this puppy up here. I want to try to hit as many points as I can, and I want to try to keep balance. So I see that 0, 0 down here, kind of wanting to go through there. And the reason I kind of want to go through there is in any given game, that's going to be a given. If no time has passed, no points are scored, period. These may fluctuate, but this one's kind of steady. So I kind of want to go through that 0, 0. Now, if I go through 0, 0, and I hit some points here, maybe these 3, ooh, look at that. I'm hitting 1, 2, 3, 4, 5 points. I'm going to do it right here. Look at that. What I love about this is I hit 1, 2, 3, 4, 5. I've got 1, 2, 3 points under. I've only got 1 point over, so the balance is a little bit off, but I'm okay with that. I'm pretty happy with this line. And let's be clear on something. If the game went further, the score would go higher. That's why I have this arrow here. And this is where later on predictions can be made. If this is the trend during the first 48 minutes of the game, then guess what? If that trend continues, I can make some decent predictions into the future. Okay, so the next part says, hey, write the equation of your best fit line. Well, to write an equation of any line, there's something that you need. First, you need the form that you want to write your line in. And for me on this problem, I don't know about you, I like slope-intercept form. So the very first thing I'm going to sketch down is y equals mx plus b. And I need to find two things. I need to find the m and the b. Now, lucky for me, I went through 0, 0, so I can clearly see my y-intercept. My b is right here, 0. But my slope is not as easy to detect. So what I like to do to find slope is I like to pick 2 points on my line. Now, surely I'm using 0, 0 because that is easy to work with. So my x sub 1 y sub 1, my first order pair, is going to be 0, 0. Now my second order pair, what's interesting is it can be any point on this line. So I can use this guy, I can use this guy, I can use this guy. Those are actually straight from my data set. But I want you to know, you don't have to use those. You can use any point so long as it's on a corner and you can really read it accurately. For example, I would say this line strikes right here. See? Even though that red dot, it wasn't part of my table. The dot's a little under here. That purple dot was actually the data set, but the line goes through 30, 77. Okay, do I have any other corner points? Not really seeing much here. So maybe a little higher here, maybe right here. This would be like 48, 126 if I go up by 7s. Okay, you get the idea? I think just to show you that this will work well, I'm going to use this red dot here at 30, 77. So 30, 77 is on my line, even though it wasn't part of my set. What you do not want to do is use these points that are off the line. It would not make sense to use him, 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 or him. They are not even on the line, so it wouldn't make sense to use those. Okay, so my slope, we know the chant. It's the rise over run, y2 minus y1 over x2 minus x1, cha-cha-cha. So, y2, oh, I forgot to label my other point. So this is x sub 2, y sub 2. Okay, so y2, y sub 2 is 77 minus y sub 1, 0, over x sub 2, 30, minus x sub 1, 0. So this is easy. This is just 77 over 30. Now let's talk about what that means. This is so great. Finally, real world stuff. 77 what? Well, 77 is the change in y. How was y measured? Points. So this represents 77 points for every, what was x? X was minutes. Minutes. So this is a rate of change. Check it out. It's a per. So this means the Chicago Bulls are scoring 77 points every 30 minutes. Very cool. Now say we want to get it down to what they're scoring each minute. Let's divide. So let's divide 77 divided by 30. Okay, so they're scoring about 2.56 repeating points every minute. Now, for accuracy, I should leave it like this, but I'm going to round to the nearest point. So if I take this 5, that would round the 2 up to 3. So I'm going to say about, this is approximately, the Chicago Bulls are putting up 3 points a minute. Okay? The Chicago Bulls in this game are putting up around 3 points with every minute that passes. So here's what I've got for my equation. Y equals 3x plus 0. Remember my b was 0? Or if I just want to write it as y equals 3x, that's fine. What this tells me is that the point scored right here is equal to 3 points per minute times the number of minutes that we play. Okay? Let's think about a reasonable domain and range here. Since we just studied that, let's set the template. Okay? How far left does this line go? Well, I would say 0. And the reason I say 0 and not negative infinity is because time is positive. So I only start my minutes after I leave 0. So 0. And how far right does it go? Well, I'm not exactly sure. How long does a regulation NBA game last? I mean, Danique went up to 48. Boy, oh boy, I'd almost have to Google this. Let me grab my phone quick. Hey, Siri. How long is an NBA game?
There are 14 NBA games today. The Wizards face the Hornets at 7 p.m. The Nets battle the Cavaliers at 7
That's not what I asked,
The
Siri.
Trailblazers meet the
Okay,
Clippers.
bye-bye, Siri. Okay, what I'm going to do is I'm on my phone. I'm going to Google this. So, how long does an NBA game last? Oh, are you kidding me? It's 48 minutes. Can you see that? Right here, 48 minutes. So it didn't cut out early. An NBA game is 4 quarters of 12 minutes each. Well, I'll be darned. I thought it was 60 minutes. Okay. Well, that's that. So a reasonable domain is 0 to 48 minutes. So now, a reasonable range. This is a little bit harder. Remember, time is fixed. You're not going to change time. How many points they put up, that is going to change. But reasonable, well, they could score nothing. I mean, technically, they could score 0 points. How many points here would they score in a 48-minute game? Well, if they're putting up 3 points a minute, let's take 48 times 3. So 100, if we're going at this rate, we'll say about 144. Now, is that really the top? No. I mean, they could have a killer game and like get crazy and score more than 144 points, but we're saying reasonable. So check that out. Love it. Domain and range in the real world. Okay. Last question and we're out of here. Predict. Love it. That's what best fit lines are for. Predict. How many points the Bulls would have scored if the game lasted 100 minutes. So say this game went out and on and on and on 100 minutes. So we're way down here at 100 minutes. Minutes is X. So I hope you're thinking all you got to do is take your equation of your best fit line. Here's your predictor. Points would equal 3 points per minute times 100 minutes. 300 points would be our prediction. So if the Bulls continue to perform at this level, scoring 3 points with every passing minute, then by 100 minutes, they are going to score 300 points. This is really awesome, guys. This is how predictions are made in math. You look at data, you plot data, you look at the trend. Is it positively correlated? Is it negatively correlated? Does it look like it could be linear? If so, write an equation that models the data, and then you can use it to make predictions into the future. Very cool. So I think that's a great problem. It's real world data. Hopefully you enjoyed that and it made best fit lines make even more sense. Thanks for watching.